And now we're starting our segment on limits. All right, so here we're taking the limit as x goes to infinity of x squared over e to the x. Now notice that the numerator is going to infinity and the denominator is also going to infinity. So this is of the form infinity over infinity, and that means we can use L'Hopital's rule. So L'Hopital's rule says that a limit of this form or of the 0 over 0 form is equal to the limit, the same limit where we differentiate the numerator and denominator. So let's do that. And we end up with another quotient or another limit, and the numerator here goes to infinity and the denominator as well. So once again, we're in the infinity over infinity situation. And once again, we're going to use L'Hopital's rule. The numerator has derivative 2, the denominator has derivative e to the x. Now we no longer have a limit of the form infinity over infinity. The top here stays at 2 and the bottom's going to infinity. So this limit is equal to 0. Okay, here we have the limit as x goes to 0 of x squared over sine x. Well, the numerator is going to 0 and the denominator is going to 0 as well. Sine 0 is equal to 0. So this is a limit of the form 0 over 0. So that's another situation in which we can use L'Hopital's rule. So let's do that. Differentiate the top and the denominator. Derivative of sine x is cosine x. And now the numerator goes to 0, but the denominator is going to 1. So this is of the form 0 over 1, and that's equal to 0. Here we have a limit where we have x in the base and x in the exponent of this exponential expression. Whenever we have a limit of that type, we, instead of taking the limit of the expression, we take the limit of the log to bring down the x. So let's do that. So what we're going to do is we're going to put y equal to 1 minus 1 over x to the x. So that makes ln y is equal to x ln 1 minus 1 over x. And we're going to do the limit as x goes to infinity of ln y. So that's the limit as x goes to infinity of x ln 1 minus 1 over x. All right, now this first factor is going to infinity. X goes to infinity. And the second factor, as x goes to infinity, 1 over x goes to 0, and ln 1 is 0. So this is a limit of the form infinity times 0. And we can always change this into the form either infinity over infinity or 0 over 0 by changing one of the factors, rewriting one of the factors. Instead of multiplication by x, we're going to divide by 1 over x. So let's do that. So here we have limit x goes to infinity, and on top we get ln 1 minus 1 over x, and instead of multiplying by x, we're going to divide by 1 over x. And the reason why we did this is because now this limit changed into a 0 over 0 limit, and we can use L'Hopital's rule. You see, this is now going to 0, and the top goes to 0 as well. So we can always do that with an infinity times 0 limit. All right, so we're going to take the derivative. Now this is a 0 over 0 limit, so we can use L'Hopital's rule. So we'll take the derivative of the top and the bottom. All right, the derivative of the top is 1 over 1 minus 1 over x. And now the derivative of the denominator is 1 over x squared. And the derivative of this denominator is minus 1 over x squared. We have some canceling going on here, so let's do that. Let's simplify this. So this is equal to limit x goes to infinity. And we're canceling this 1 over x squared with this 1 over x squared. And so we end up with 1 over 1 minus 1 over x. And we have this negative here. Well, I'll put that up here. As x goes to infinity, 1 over x goes to 0. So the limit of this expression is minus 1. So what we found was the limit of ln y. So in other words, we saw that ln y tends to minus 1. Now just raise both sides to e, okay, or exponentiate both sides, and we have y tends to e to the minus 1. So that's our limit, e to the minus 1.